Right, in this video we're going to look at areas of different shapes. Okay, so we're going to start with triangles here, and you can see I've drawn two different sorts of triangles. Everybody, I hope, knows that the triangle area is found by doing the base multiplied by the height and then dividing all of that by 2. Now the important thing is that height measurement there. It must be the perpendicular height. Perpendicular meaning right angle height. Okay, the right angle height, the perpendicular. So let's identify the perpendicular height here. Hopefully we can see it is here. That is the perpendicular height. So if we imagine that perpendicular height is, say, 8, and we'll make it 8 centimeters, and the base here is 10 centimeters, then the area that we have is 8 times 10 divided by 2, which is 80 divided by 2, which is 40 centimeters squared. So now let's look at this type of triangle here, where it's not obvious where the perpendicular height is. However, somewhere they would tell you this distance here, because that is the perpendicular height of that shape. There is a right angle there, and that might be 6 centimeters. This here is the base, therefore, and this might be 7 centimeters. So therefore our calculation is 6 times 7 divided by 2, which is 42 divided by 2, which is 21 centimeters squared. Now, why I've chosen a shape like this is because it's a little bit like the idea of a parallelogram. Now, that there is the perpendicular height of a parallelogram. If we make that 4 centimeters and we make this 10 centimeters, what we have to remember about a parallelogram is that here and here are similar exactly the same side lengths, and here are exactly the same side lengths. Basically, a parallelogram is a rectangle that's been pushed over. So we know what the formula for a rectangle is. It is base times height. And that's exactly the same for the parallelogram. So this is 4 times 10. This is 40 centimeters squared. The trapezium comes in all shapes and sizes. If the angles are exactly the same down the bottom here, it's called an isosceles trapezium. It's a bit like an isosceles triangle that's been cut in half. If it's like this, it may have a right angle here. But the important bit about a trapezium is to identify its parallel sides. Now in my two diagrams they are both at the top and the bottom. The trapezium could be the other way around, and they could be at the side, so be careful. These sides are labelled A and B. A and B. The formula for a trapezium is A plus B divided by 2, the average of the two sides, times by, again, the perpendicular height here. The perpendicular height. So if this one here was 5 centimeters, and this was 7 centimeters, and this was 3 centimeters, we would have 5 plus 7 divided by 2 times 3. 12 divided by 2 times 3. 6 divided by 6 times 3, which is 18 centimeters squared. And the last shape here, which I'm just going to mention, is the kite. Let's have a look at some of its properties. If it was drawn properly, you would see that that side is the same as that side, and these two sides are the same. And if we draw a line across here, which is called its diagonal, we end up with two isosceles triangles. You could work out the area of this one and the area of this one, and especially if you looked at it this way round, you actually have two triangles that are actually congruent to each other, so you could work out the area of this top triangle and double it to find out the area of this one. So that's a brief introduction to the area of different shapes.